Alright, hello and welcome to Lab 5. So this one is about rational numbers, which is just a fancy word for fractions. We'll talk about that in a second. But I do encourage you to start this one sooner. Lab 4 is due in 2 weeks because of your midterm, but Lab 5 is due a week after that. And I encourage you to take 1 week to do Lab 4, and then use 2 weeks to do this one because it's a bit harder. Okay? So that is my recommendation. Let's get started now. So we're going to make our own little library that handles rational numbers, which are just fancy words for fractions. A rational number is any number that looks like a over b, where a and b are integers. They can be negative, but they can't have decimal places. It has to be whole numbers on the top and the bottom. Okay? So that's all a rational number is. Things like 3 over 14 is a rational number, and so is 5 over 10. But 5 over 10 can be simplified to 1/2. And we're going to work on that simplification process in this lab. Okay? So it's all going to be very fun. So get the code as usual. We have these 4 files, and let's talk about the library part, the rationals library. Okay? So, rationals.h holds all the declarations of the functions you're going to implement, and then you'll go and implement them in rationals.cpp. Okay? So definitely read all of this. Let me just give you the high-level overview. The write-up and the comments are going to be very, very useful. Okay, so these are the 3 functions that you're going to write. Rational pretty string, which is going to take a rational number represented by a numerator and a denominator, and give back a string form that looks all nice and pretty. Like it will convert rational pretty string of 5 over 10 should give back the string 1 over 2 with some cool spaces and things like that. Okay, so that's what that function is going to eventually do. It will simplify the fraction. And then rational times is going to multiply 2 rational numbers and give back the result using references because we have 2 things to give back. Okay, so you have a numerator and a denominator for the first fraction. Same for the second one, and you want to multiply them together and set the result numerator and the result denominator. Okay, the .cpp file has a ton more comments, don't worry. And then also simplification. So you're going to take a reference to a numerator that you can then fix and make smaller, right? And then a reference to a denominator of the same fraction. And you will change these to be the simplified version of the fraction. Okay, so that is what you're going to do there, and let's go to rationals.cpp. And there's a ton of comments. This is all you need to implement this. Okay, so the first one is simplification. That one's not too bad because the greatest common divisor, which I've implemented for you, does all the work. Okay, this calculates the greatest common divisor of a and b, and that is that. And these numbers that you give to GCD have to be positive. They have to be non-negative. So we have to deal with negative things first in this function. Okay. So just follow all these comments. It's going to work out. The first thing you do is figure out if the number that you're given is negative. And it's possible that the numerator is the one that's negative, or maybe the denominator is the one that's negative. One of those things is going to tell you if it's negative. If they're both negative, then it's positive, things like that. So you'll have to look into all of that. And then so that you can use GCD, you'll have to get rid of the negativity. So you can use the absolute value function if you'd like, but whatever you give to GCD has to be positive, okay? And then you can simplify numer and denom using the GCD, and this is what's going to happen. Okay, so pretend that your numer was 5, and your denominator was 10. It just so happens that the GCD of both of those numbers is 5, because 5 goes in to 5 and 10. And that's the biggest thing that goes into both. That will give back 5, and you can use that 5 to divide, okay? So we do 5 over 5, which equals 1. And you can do integer division because you know there's nothing left over. It's a divisor. It goes into both of them cleanly. And then 10 becomes 10 over 5, which equals 2, okay? So that's how you can simplify a fraction using GCD. Okay? And then remember, if it was negative, you should negate numer. So that's a nice pretty fraction where it's the numerator is the one that's negative. And actually that's it, because you update numer and denom in this function they were passed by reference, you don't have to return a thing. You did your work by changing these values. Okay? Please yell at me if any of this is not making sense, but hopefully that's not too bad. And then for times, remember how to multiply two rational numbers. Let's see, do I say it down here or anything? No. Let me show you on this. Well, if you have two rational numbers like a over b and c over d, and you want to multiply them, well, it's just ac over bd, right? Not too bad. And then you go and simplify this. Okay, so you're going to be using that simplification function all over the place. So it's good to get it done first. All right, so then times, it takes two fractions, the first one and the second one, with its numerators and denominators. And then it's going to take the result, numerator and denominator, that you're going to change and set to be whatever the answer is. Okay? And then make sure to simplify as well, because it's most likely the case that you're going to end up with a large fraction that could be simplified. Okay, so just remember to call simplify on your result numer and your result denom. Okay? It's getting cut off because I made the font giant. Okay. And then finally, we have rational pretty string in this file. So what you do for this one is you return back a string. So given a numerator and a denominator, you need to simplify it first because it needs to be nice and pretty, and then you're going to return back a string. Right now I just gave you a stub function. You're going to give back a string that looks nice and pretty. So it's going to be the numerator space slash space denominator. Okay? And so you're going to have to convert your numerator and denominator to strings so that you can add them together. But that is the idea. You're going to take 5 over 10 and give back the string 1 over 2. Okay? So that is everything you need to do in the .cpp file. And I've given you a nice little sample program that you can run with this library that can test if you're doing things correctly. Okay? So it's going to get two fractions. It will simplify the first one, and then it will multiply the second one and call the pretty string on it after multiplying it. So definitely look at this file. This is what you should use to see if you're doing it right. Okay? So definitely run that program. Make sure it's getting everything back that it should. So for example, if I type in 2 over negative 22, that's the first fraction, and then 4 over 8, that's the second fraction. You should be able to simplify the first one to negative 1 over 11, like the minus sign is now over the numerator. If you follow all of the instructions, and it will. Then the second number, if you do pretty string, it will simplify it automatically. And then multiplying them, and then pretty stringing that, will produce negative 1 over 22. Okay, hopefully that is making sense to you, and that is what your program should look like when you run it with those inputs. And definitely try it for others, of course, because I'm going to test you on just more than that. Okay, so after you've done all of that, I have made tests. Okay, we talked about tests. Those are going to be the real ones that I'm testing you on. Okay, that's where your grade's coming from, these tests in test.cpp. So I want you to look at this file now and make sure that everything passes. So I've made this assert true function, and what it does is it takes a Boolean value, and we hope that it is true because I want to assert the fact that this Boolean b is true. And I also give a string description of what the test is. So if this Boolean is false, that means we failed the test. Otherwise, we passed it. So we want to see passed everywhere. I've made 3 functions that test right now, and it's your job to write 2 more. But let's talk about those first functions. So the first one is like, okay, take 2 fractions, or 2 numbers that represent a fraction, and it simplifies them. That's the name of the test. And then we make sure, we're asserting true, that after simplifying, the numerator is negative 1, and the denominator is 22 now. They got changed, right? So that is what simplify should have done to these numbers, to this fraction, and we're asserting, we want to make sure that this passes. We want to make sure that this is a true statement, that we get back the right things. Okay? And same for test times and test pretty string. Hopefully you can see what it's doing. It's testing to make sure that all of these things are correct. Okay? So all of those are your tests. After you've got everything working with the sample program, go and compile and run the test program and make sure you get passing things. Okay? And after that, it's your turn to write 2 extra tests using the same style. They got to print pass like that. So you'll just call assert true, of course. So make 2 more tests down here in main, and that is your entire lab. Okay? It sounds like a lot, but it was more explanation than actual implementation. Okay? I can promise you that. So you're going to write your own tests, and then you're done. You submit your code. You'll submit the tests that you wrote, and then also your implementation of the rationals library. So that is everything. And here's the rubric. I think that's all. So again, a recap of what you're going to do. You're going to implement every function in rationals.cpp. Well, one's already given, so you're going to implement these 3 functions: simplify, times, and pretty string. And I think I've given you enough examples now to do that well, and definitely pay attention to the comments. That should help you very, very much on this. Yeah, I think that's all for that one. So only really 3 functions. I just took a while to explain them to make sure you understand them. And then you're going to make sure that the tests pass. So that shouldn't be any extra work on your part if you did rationals.cpp correctly. But maybe there's an error and you'll have to fix it. And then you'll just make 2 more tests in this style. You can copy this, but it can't be the exact same, of course. So make a nice test that's helping you convince yourself that your program is correct. So that is test.cpp, and those are the 2 files that you'll edit: rationals.cpp and test.cpp. Okay, so I think that is officially everything. Please yell at me if you have any questions, and I encourage you to get Lab 04 out of the way and do this one, because it is a few more things to do than Lab 04, in my opinion. Okay, so that is Lab 5. Good luck, and I will see you soon.